morning all. Welcome to my channel Vijay's Physics Print. So ఈరోజు క్లాస్లో 10th క్లాస్ సిలబస్లో కూడా కరెంట్ ఎలక్ట్రిసిటీ టాపిక్ చూస్తున్నాం. సో లాస్ట్ క్లాస్లో సిరీస్ మీన్స్ రెసిస్టెన్స్, వాట్ ఈస్ రెసిస్టెన్స్, రెసిస్టివిటీ, కండక్టివిటీ ఈ టాపిక్స్ డిస్కస్ చేసినాం. ఈ రెసిస్టర్స్ని ఈరోజు క్లాస్లో కూడా ఎన్ని రకాలుగా కలుగుతూ ఉండొచ్చు, ద కాంబినేషన్ ఆఫ్ రెసిస్టర్స్ ఈరోజు క్లాస్లో డిస్కస్ చేద్దాం. So totally we have two types of combinations. One, it is series combination of resistors. Series combination of resistors. What do you mean by the series combination? In Telugulo శ్రేణి సంధానం చెప్తుంటా. So series combination లో కూడా ఈ resistor ఏదైతే ఉందో, right, this is the resistor. First resistor, second resistor and third resistor, R1, R2 and as well as R3. The second end of the first resistor connected to first end of the second resistor. Second end of first resistor connected to first end of second resistor. And second end of second resistor connected to first end of third resistor, second first. So itla kalipte ganaka in series combination ani cheptam. So three resistors R1, R2, R3 vidini series lo kalipestam, the series combination of the resistors. And applied EMF, it is E, or voltage which is equals to V is the voltage, and current through the circuit, it is I. Through the first resistor, I. Same current follows the remaining resistors R2 and as well as R3. So in series combination, the current passing through all the resistors is same. The current passing through all resistors is same. So I is constant, but applied potential is divided among the given resistors. So the first resistor potential drop is V1 and second it is V2, V3. Potential drop across first resistor R1, second resistor V1 and second resistor is V2 and third resistor it is V3. Now the total applied voltage V is equal to sum of the voltage drops across the resistors. So V equal to V1 plus V2 plus V3. So V is equals to V. According to Ohm's law, V equal to IR. So V1 is equals to I into R1. Second, it is I into R2. And that is third, I into R3. If replacing all these three resistors, which is equals to the another resistor taken as RS. So we also replaced as I into RS. I is taken out. R1 plus R2 plus R3. So I is cancelled. So the resistance, the equivalent resistance in series combination RS is equals to R1 plus R2 plus R3. The effective resistance in the series combination RS is equals to R1 plus R2 plus R3. So this is the first point. The current through all the components is same in series combination. And second, the total resistance is equals to R1 plus R2 plus R3. Take the sum of all the given resistors. If n resistors are there, you can take up to so on or n. Now, third one, the ratio of potential drops V1, V2, V3. The ratio current it is same, I is cancelled out, which is equals to R1, R2, R3. Okay, series combination low current అన్ని రెసిస్టర్స్ నుంచి కూడా ఈక్వల్ ఉంటుంది. సెకండ్ పాయింట్, ఎఫెక్టివ్ రెసిస్టెన్స్ అనేది అన్నిటి రెసిస్టెన్స్ కి సమ్ కి ఈక్వల్ వస్తుంది. RS is equal to R1 plus R2 plus R3 up to so on. And the voltage drop ratio మనం ఫైండ్ అవుట్ చేస్తే which is equal to ratio of the resistors R1, R2, R3 up to so on. Like any doubts here? Right. So this is the series combination of the resistors. So this is series combination. Now parallel combination of resistors. Parallel combination of resistors. ఇది రెండో రకమైన కాంబినేషన్. ఇది parallel combination లో ఏమవుతుంది, this is the first resistor R1, second resistor R2, and third resistor which is equal to R3. The first ends of the all resistors connected to one common point. This is a common point. Second ends are connected to another common point. Series combination lo second end తీసుకొచ్చి ఫస్ట్ ఎండ్ కి అలా యాడ్ చేసుకుంటూ పోయాం. ఇక్కడ ఫస్ట్ ఎండ్స్ అన్ని ఒక కామన్ పాయింట్ కి, సెకండ్ ఎండ్స్ అన్ని కూడా ఇంకో కామన్ పాయింట్ కి యాడ్ చేస్తే దట్ ఈస్ నోన్ యాజ్ parallel combination. All the first ends are connected to one common point and all the second ends of the all resistors connected to one more common point, that is called as parallel combination. So I'm connected to battery of EMF or voltage V. In the parallel combination, the current passing through the circuit is I. At this junction, the current split into I1 passing through R1, I1, okay, and I2 passing through R2, I3 is passing through R3. Again, at this junction, combine I1, I2, I3, and forms current I. This is in parallel combination. So here the potential drop across all resistors remains same. No change in potential drop across the resistors. Only current is going to be changed. I1, I2, and as well as I3. But total current means I equal to I1 plus I2 plus I3. According to Ohm's law, V is equals to IR. I becomes V by R. I'm using here. So replacing all these three resistors with another resistance, V by RP is a parallel resistor. So V by R1 plus V by R2, V by R3. V is taken out and cancelled out. Then 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the effective resistance in parallel combination. The first point, total current is equal to sum of individual currents in parallel combination. Second point, the effective resistance, here reciprocal of effective resistance. After calculating, take the reciprocal, we get the resultant value. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. If it is only two resistors, then 1 by Rp equal to 1 by R1 plus 1 by R2. Taking LCM and inversion, Rp becomes R1 R2 by R1 plus R2. This is for two resistors. If it is more than 2 or more than 3 is given, just you can use this value 1 by R1 plus 1 by R2 plus 1 by R3, fourth is 1 by R4, and take the calculation. This is second point. Now, current ratio I1 is I2 is I3 equal to, potential is constant, so cancel out, remaining it is 1 by R1, 1 by R2 is 1 by R3. This is third point. Total current equals to sum of individual currents, and resistance, effective resistance 1 by Rp equals to, and the ratio of the currents I1, I2 as well as I3 equals to 1 by R1 is to 1 by R2 is to 1 by R3. Okay. So this is parallel combination. దీన్నే తెలుగులో సమాంతర సంధానం అని చెప్తుంటాం. క్వశ్చన్ ఎట్లా వస్తుంది? How the question in the examination? See, three resistors are mentioned. For example, 2 ohm, 3 ohm, 4 ohm. Three resistors are given, and how many number of possible combination? How many combinations are possible with given resistors? ఈ త్రీ రెసిస్టర్స్ ని ఎన్ని రకాలు కలపొచ్చు? హౌ మెనీ కాంబినేషన్స్, రైట్? దీనిలో రెండింటిని సిరీస్ లో, ఒకదాన్ని ప్యారలల్ లో, లేదా అన్నింటిని సిరీస్ లో, అన్నింటిని ప్యారలల్, డిఫరెంట్ కాంబినేషన్స్ వస్తూ ఉంటాయి. సో హౌ మెనీ నంబర్ ఆఫ్ పాసిబుల్ కాంబినేషన్? నంబర్ ఆఫ్ పాసిబుల్ combinations. Number of possible combination. You have to remember, right? See the question carefully. The given resistors are equal resistor or unequal resistors. These are unequal resistors. 2, 3, 4. 2 ohm, 3 ohm, 4 ohm, unequal resistors. If it is equal, for example, 3 resistors are 2 ohm, 2 ohm, 2 ohm. మూడు కూడా ఈక్వల్ ఇచ్చారు. అప్పుడు ఏమైంది? Unequal resistors For unequal resistors, the number of possible combinations are 2 power n. N is number of resistors. Number of resistors. 2 power n for unequal resistors. If it is equal is given. Equal. The number of combinations become 2 power n minus 1. 2 power n for unequal resistors. 2 power n minus 1 for equal resistors. Right? For example, you get 2, 3, 4 unequal ichadu. So n value is 3. Then 2 cube is nothing but 8. So the possible combinations are 8. Equal ichadu. Here also n is equal to 3. 1, 2, 3. 3 resistors. 2 power n minus 1. 3 minus 1. 2 square, which is equal to 4 possible combinations. Okay? So the 4 possible combinations in equal resistors. One more point. Right? See, easy calculation. 5 ohms, 10 ohms, 15 ohms connected in series. Then what is the effective resistance? Effective resistance means you can add all the resistance in series, right? 5 plus 10, 15, 15 plus 15, 30 ohms in series. In parallel, 1 by Rp equal to 1 by 5 plus 1 by 10 plus 1 by 15. So same resistors in parallel, same values. Then take the LCM, that is 30, right? 5, 10, 15 LCM is 30. So this is 6 times, 3 times, with 15 it is 2 times. So 1 by Rp equal to 9, 11 by 30. Take the reciprocal inversion. 30 by 11, it is 2.7 ohms nearly. Same resistors in series 30 ohms. Same resistors in parallel 2.7 ohms. Means in series combination the resultant value is greater than the individual resistors. The total value is greater than individual resistors in series combination. In parallel combination, this 2.7 is less than individual resistance. Okay. In series, the effectivity is more than the individual. In parallel, it is less than the individual values. Any doubts here? Okay. So if you have any doubts, just make a question in comment box. Thank you. Like, share, subscribe my channel. Support my channel. Thank you all. Have a great day.